So good morning students. Yesterday we completed our first topic of unit number first, a numerical topic of unit number first, and that was block diagram representation. With the help of that block diagram you saw we solved numericals and find out the transfer function of any complex system. Now, one another method we can say, one another approach by which we can find out the transfer function of a system of a given numerical with the help of signal flow graph. The name of that method is signal flow graph. Let's see first of all the PPT, then we will see the new formula, the technique, and we will solve the numericals. So see, I will show you just right now. Yes, so see, our topic name is signal flow graph. Actually a signal flow graph, as I told you, is an alternative to block diagram representations for graphic, and actually any system when represented by a graphical approach, that is known as a signal flow graph. A control system can be represented diagrammatically, graphically by signal flow graphs. Actually in signal flow graphs there are certain points, certain things it consists. The things are nodes, branch means that represent the system blocks, and nodes that represent the signals. Is labeled with system transfer function, nodes labeled with signal names, arrow indicate the signal flow directions. And with the help of signal flow graph, how can we find out the transfer function, as in the case of block diagram, I mean CS upon RS. So we will find out the transfer function of a control system with the help of signal flow graph, with the help of Mason's gain formula, a special formula that is known as Mason's gain formula. And Mason's gain formula to find out the transfer function of a signal flow graph is CS upon RS is equal to summation of Tk del K upon del. First of all, I will tell you what is the meaning of K. K is the number of forward path. Now, what is forward path? Forward path is when we start from the input side. Let's suppose the input side is represented by RS. We will reach at the destination. We will reach at the output side, which will represent as CS. So the transfer function means CS upon RS. Now the meaning of forward path is once we start from the starting point, the beginning point, that is input point, that is RS, the straight forward path without repeating any branch, without repeating any node, we will reach at the destination, that is known as forward path. Now in any signal flow graph, which one given in our questions, first of all the first step is we have to find out how many number of forward path are there. So we just see the numerical, see the question, see the control system signal flow graph, and then we check from the starting point till the end point how many number of straight forward paths without repeating nodes and branches. That will be equal to K. So K is equal to numeric, will be our numeric value that will show you how many number of forward path. Once we will find out the number of forward path, then all formula will be converted into a new formula, because all forward, for example, if you will find out only one forward path, then the formula for transfer function is CS upon RS is equal to T1 del 1 upon del only. If there are two number of forward path, then it will be transfer function CS upon RS is equal to T1 del 1 plus T2 del 2 upon del. One more example, if there, let's suppose there are three forward path, then my question will change from the transfer function will be from CS upon RS is equal to T1 del 1, because three forward path. So T1 del 1 plus T2 del 2 plus T3 del 3 upon del. Okay. So once you write down the formula after knowing the value of K in step number first, you will in step number second you have to write down the converted formula as per the value of K. Then what is the meaning of T1, T2, T3? What is the meaning of T? T is the gain of forward path. T is the gain of forward path. As you see in any branches, there is some value with the direction is written. In any branch of signal flow graph, you will see a value is written over a branch. That value is the gain of that branch. So in the forward path, there are number of branches, from the input side till the you will reach at the destination side. At the output side there are number of branches. So whatever the value written over there means whatever the gain of that branch is, just multiply them with each other in that forward path. That is the total gain, that is the actual gain of that forward path. So T1 is the first forward path gain, T2 is the second forward path gain, T3 is the third forward path gain, and so on. So like this one. What is the meaning of del 1, del 2, right? So in the Mason's gain formula, once you see the diagram, find out the number of forward path, converted the formula on the basis of that, find out the forward path gain T1, T2, then the step number 4th is you have to find out the loop gain. What is the meaning of loop gain? You have to find out the loop gain. What is the meaning of loop? Loop means once you start from a node, you will again reach up to that node without repeating any branch. Without repeating any branch or any node, once you start from a node, you will reach up. We can say in a simplified manner a closed path without repeating, without repetition, a closed path. So once, first of all, in step number 4th, you have to find out the different number of loops, and there you have to write down the loop gain, right? And then you have to see what is del 1, del 2, and so on. Del 1 is among all those loops which you just calculated in step number 4, which loop do not touch the first forward path. Del 1 means which loop do not touch the first forward path. Similarly, if del 2 will be there, what is the meaning of del 2? Which loop do not touch the second forward path. Similarly, if third is there, del 3 is also there, it means which loop do not touch the third forward path. So del 1, del 2, del 3 are just the loops which do not touch the forward path. If all the loops touch the forward path, particular forward path, then the value is equal to 1. Now what is the meaning of del? What is the meaning of del? I also write down these all things which I told you earlier. So forward path gain K is the number of forward path of the signal program. What is the meaning of del? Del is 1 minus sum of all the individual loop gains plus sum of all the two non-touching loop gain products minus sum of all the three non-touching loop gain product sum, and so on. Okay. So now without the numerical we can't understand this whole formula. Once we see the numerical, first we start with the simple numericals, find out these values, then complex, and then complex numericals. Okay. So in those numericals you will easily understand what I mean. So now see, let's suppose we have certain numericals, and I will show you on a MS Paint file. So you will feel a blackboard type of pedagogy will be there. So now see. Yes. See this one, MS Paint file. Okay. Now your first question is, a diagram is given. You are able to see. I just took it from that PPT. The first numerical, right? This is a signal flow graph. Nodes are, these are x1, x2, x3, x4, x5, x written over arrow are the gain of particular branch C, right? And loops are what? A closed path. So where is the closed path? C, in between x2 and x3 there is a closed path where I just move the cursor, and in between x4 and x5 there is a closed path. So this is also a loop. Okay. Now what is my question? My question is, it is a signal flow graph. You have to find out the transfer function, and what I know from the formula of transfer function, I just write down the same thing. Cs in caps lock I will write down, in the caps lock I will write down upon RS. You don't confuse kindly from the words CS and RS, because the output side, for example, in this numerical represented by x6 and the input side is represented by x1. So you can also write down x6 by x1, no problem. Otherwise the standard transfer function that, so CS upon RS is equal to upon del Tk del K upon del. Kindly wait. Yes, kindly wait. Yes. So in like this numericals, you will easily understand. For example, now what we want T1 del 1 upon del, T2 del 2 upon del, T3 del 3 upon del, like this one. For that, first of all, we just write down the formula. So our formula is kindly wait once. Yes. So again, I start now. See this value. So Tk del K upon del, Tk del K upon del. Right. Yes. So this one is my formula, Tk del K upon del. Sorry for the interruption, because my okay, Tk del K upon del. So the first step is what? Now this is my formula as I told you in that PPT. Now we start for this numerical very carefully. So what is the first step is what? We have to find out the value of K. Now what is the meaning of K? K is number of forward path. Now how you will find out the number of forward path? How you will find out the number of forward path? Just once we start from the input side, we will reach at the output side without repeating any branch or node, that is known as forward path. So see, from this red color, I just draw with the help of a pencil. See the forward path. I start from x1, that is input side, A, then B, then D, then E, then G. These are 5 gains on the branches. So what is this is my first forward path. We select the forward path direction depends on the given direction of the arrow in the question. So see, I start from x1, the direction of arrow is towards x2, the direction of arrow towards x3, the direction of arrow towards x4, the direction of arrow towards x5, then the direction of arrow towards the last node x6. So this is a straightforward path without repeating any node or branch, So this is my first forward path. Now any other forward path is there? I just check. I start from x1, reach up to x2, but I can't reach up to x3 via the gain C, because the arrow direction is opposite. So this is not a forward path. Then x1 up to x2, then x3, then x4. I can't reach up to x5 via the node, via this branch, because the direction of f is opposite to my direction. So only one forward path. So I just write down after this that I have only one forward path. Now because I have only one forward path, what is my next step? As I told you, I replace the formula, depends on the value of K. So what will be my formula? Now my formula for this question actually is CS upon RS is equal to, only one forward path is there, so just write down the value over there, T1 del 1 upon del. So T1 del 1 upon del, so this one is T1, this one is del 1 and divided by 10. Now this one will be my formula. I have to find out only the value of T1, only the value del 1 and then put the value of del, then my answer will be completed. Now I check what is T1. As I told you, what is the meaning of T1? T1 means the first. What is the meaning of T? T means T1 is that it means the first forward path gain. Okay. So what is T1? Now see what is T1. How to find out the first forward path gain? To find out the forward path gain of any forward path, to find out the gain of any forward path, you just see the forward path and whatever the gain of each branches you will see in that forward path, multiply with each other and write down. That will be the actual gain of that particular forward path. For example, here only one forward path which just denoted few minutes ago by a red color pencil in that diagram. Now see that forward path. First A will be there, then B, then D, then E, and then G. So A, B, D, E, G is the first forward path gain. So I just write down the value of T1, that is A, B, D, E, G. Okay, this one is my first forward path gain. This one will be my first forward path gain. Now what is my next step? Step by step we solve in every question. First of all, by see the numerical, first of all you should know about the formula. Then the next step is find out the value of number of forward path. Then on the basis of number of forward path, in next step convert your formula on the basis of number of k. Only one is there, k is equal to 1 here. So only T1 del 1 upon del. If k, for example, if k will be 2, then what will be my formula? In this step, Cs upon Rs is equal to T1 del 1 plus T2 del 2 upon del. Okay. Then what will be my next step? Find out the value of forward path gain. So here only one forward path, so I just find out the forward path gain A, B, D, E, G. Okay. Now what is my next step? Color to this one because one thing I find out. Okay. Now what is my next step? Find out the number of loops and loop gain. So number of loops I will find out. Now how many closed paths are there without repeating the node or branch? Now see with this blue color I just see closed path. Okay, now see I start from x2 reach up to x3 depend on the direction of the arrow, then again reach at the same node because of the direction of C, and this is a closed path. Okay, so this is a loop, perfect loop. So this is a loop number 1. Now see with this green color another closed path. I start from x4 node reach up to x5 node, then on the basis of direction of F branch I will again reach at the x4. So this is also a closed path. So actually there are two closed paths. Okay, so how many number, and the closed path is known as loop. So how many number of loops are there? There are two number of loops. Okay, so now the next step is write down the gain of those loops. Loop can be denoted by L. Loop can be denoted by L. So I just write down here. See carefully. I just write down here. Now I start from here. Okay. Now see. So how many number of loops? Loops are 2. So these will be L1 and the second one is L2. Okay. Now I have to find out the value. L1. So what is L1? In the blue color loop, okay, I just write down with the same color so you will not confuse. So L1 will be L1 equal to, now see, yes, so L1 will be, so what was my loop? BC, there in that loop there are two branches and the branch gain, just multiply their gain, B and C. So BC. So BC is my first loop gain, BC. And what is my second loop gain? Because I encircle that second loop with the green color, so I just write down with the help of green color. Now see what is my second loop gain. EF is my second loop gain. Okay, so I find out the L1 and L2, the loop gain value. I again repeat once. First of all, write down the formula, then find out the number of forward path. Depends on the number of forward path gain, K, forward path depend on the number of forward path K. Replace the formula again, Cs upon Rs will be replaced. Then find out the gain, the forward path gain, T1, T2 till 3 depends on the question. Then find out the number of loops and find out the number of loop gain. Now how to find out the del 1, del 2, del 3? Here only del 1 is present, so first of all you should know what is the meaning of del 1. Del 1 means which loop do not touch the first forward path, which loop do not touch the first forward path. Now see in this question, with the red color line I just show the forward path direction and forward path, because the first loop, this blue color encircle loop, one branch is B which is on the same forward path, because forward path also consists this branch, so it touch. Now the second loop with the green circle and green encircle, you see it also touch the forward path because E branch is there. Okay, so both the loop touch the forward path, both the loop touch the first forward path. Here only one forward path is there, so both the loop touch the forward path. Then what is the value of del 1? When no loop touch, when all the loop touch the forward path, it means the value of del 1 is equal to 1, because both L1 and L2 touch the first forward path. I just write down for your remembrance in bracket, because both loop touch the first forward path. Okay. Okay, so this one, because both the loop touch the first forward path. Okay, now I encircle it with the pencil, because I think I find this del 1 value in the formula. Okay. So T1 I find out, then I find out del 1. Now what is left? I only have to find out what the value of del. So the next step is how to find out the value of del. So I know del is equal to 1 minus sum of all the individual loop gain. Once I write down the formula, then I will show you, plus sum of products of two non-touching loop. Minus, and so on, it will continuously increases, sum of two non-touching loop, sum of three non-touching loop, and so on like this one. Okay, so 1 minus sum of all the individual loop gain plus sum of product of two non-touching loop minus sum of product of three non-touching loop, and so on and so on, and right. For this question we see 1 minus sum of all the individual loop gain. So loop gain we have already will find out. See in this orange color, one loop is L1, one loop is L2. We already find out in the previous steps. So 1 minus sum of all the individual loop gain. So 1 minus sum of L1 and L2 plus sum of product of two non-touching loop. See whether these, here only two loops are there. So check whether these two touch each other or not touch each other. So see, this BC loop and this EF loop are separated from each other. They do not touch each other. It means they are non-touching loop. So and then three non-touching loops. So here only two loops are there. So we have to stop till now, till this step. So how to find out the value of del for this question? Now see very carefully. So del is equal to 1 minus sum of all the individual loop gains. So here there are only two loops, one is BC and plus which one is second loop? EF. Okay, 1 minus BC plus EF plus sum of product of two non-touching loops. So see where is that two non-touching loop? One is BC loop, L1 loop do not touch the L2 loop. It means these two are non-touching loop. So products, just sum of the products, but here only product of BC EF is there. Okay, so this will be your answer for del. Now I again encircle this because one more thing I find out for the formula for this question. Wait. Yes. So now the question is completed if we put all these right value like T1, del1 and del value in the basic formula of which we denoted for this question. So now see what will be my answer. Here I write down the complete answer. So CS upon RS is equal to T1. T1 is A, B, D, E, G. Divided by T1 del 1 because del 1 is 1, so there is no meaning to write down here upon del. So what is del? Del we just calculated. Del is this one. I just remove this. Okay, so this one is your final answer. So I just okay, so this one we find out the answer with the help of Mason's gain formula. Okay, so this question is completed. Now we will see one more question. Wait, I just save the file. Now see the next numerical. So let's suppose this is my numerical. Alright. Now I have to find out the same things, transfer function and so on. So I just first of all write down the formula as we write down previously. So I just copy the formula. So time will be saved. Okay. So the first step is, first you should know the basic formula to find out the transfer function of any signal flow graph using Mason's gain formula. And what is my formula? CS upon RS is equal to T1 del 1 Tk del k upon del, where the value of k denoted the converted formula. With the value of k will denoted the number of forward path, and on the basis of that number of forward path we will convert the formula. So for this question we will see input side is R, output side is C. So C upon R we have to calculate. We generally write down in Laplace CS upon RS, no problem. So C upon R or CS upon RS we have to calculate. So the first step is find out the number of forward path k. So see, we just check how many number of forward paths. So see, with the purple color I just denoted the forward paths. So let I start from the R node, reach at x1 node, reach at x2 node, reach at x3 node, reach at output node. So I start from input side and I will reach at output side without repeating any node or any branch, depends the arrow given in the question. So arrow is, all arrow are toward the forward direction. So this is my first forward path. So this is one forward path. Okay, now check either any other forward path exists or not. So let I check with this light blue color. Now see, I start from input side, then I jump from x1 node toward x3 node, then reach at the output side. Okay, once again I find one more forward path, because once I start from the input side I will reach at the output side without repeating any node or any branch. So this is my second forward path. Now I check once again. So I start from R and reach at x1, but I can't reach at x2 directly via this branch of whose gain is minus h, because the direction is opposite. Okay, so there are only two forward paths. So there are two forward paths. So what is the answer of this step? How many number of forward paths are there? There are two forward paths. So now what is next step? Just write down the converted formula, or so I write down here. Okay, so their space will be saved. Okay, now so what will be my new formula for CS upon RS, which I have to find out for this question? So it will be, depends on the value of k, because k is 2 here. So t and del are 2 times. I have to write down, and so t1 del 1 plus t2 okay, now see, because k is equal to 2, so 1 is for t1, 1 is for t2, 1 is for del 1, 1 is for del 2. Okay, t2 and del 2. Yes. So T1 del 1 plus T2 del 2 upon del, when I will find out T1 value, T2 value, del 1 value, del 2 value and del value, and I already been find out that there are two forward paths. It means I have to only find out the remaining things. So now see, the next step is find out the forward path gain T1 and T2. So now we just find out the forward path gain T1 and T2. T1, and the second one which I have to find out for the forward path gain is T2. Okay, now in the same color I write down, so you will not disturb. So purple color for the first forward path. See, the no meaning of color, I just show you that, so you will not escape from the data and the graphical representation. Okay, so in the questions I just mark with the help of a pencil purple color the first forward path. Now I have to write down the gains. So what is the rule? Just see the forward path and whatever the branches come, just write down their gains and multiply the gains with each other. That will be your answer to find out the gain of a particular forward path. So see, the first forward path is a start from R. Now first arrow without consist anything thing written over there, so it means one gain is there for this branch. Then I reach up to x2 and g1 is written there, so 1 into g1, then x2 up to x3, 1 is there, so 1 into g1 into 1, 1 multiply by g1 multiply by 1, then we will reach at the output node without written over there, so it means 1. So g1 is the only written thing, so I just write down g1 for first forward path gain to denote the first forward path gain. Okay, now we have to write down for the second forward path, so I just write down over here. What is my second forward path gain? Now see, with this blue color, light blue color I just mentioned in the graphical representation. See, I start from the input side R, reach at x1 node, nothing is written for that branch, so it means gain is 1. Then I will reach at x3 branch directly with the help of this branch whose gain is g2, so 1 into g2, 1 multiplied by g2, then I will reach at the output side without written over that, so 1, so 1 multiplied by g2 multiplied by 1, so g2 is the gain of this second forward path. Okay, so once you will find out, just encircle them because these are, I just encircle them, so you will understand that these are one part of my answer which I find right. Okay, so T1 and T2 I find. Now what is next step? The next step is find out the number of loops. So I just write down here number of loops. So number of loops, so once again I repeat, what is the meaning of loop? Loop is a closed path, no repetition of branch and no repetition of node. With this red color I draw the first loop. See, I start, then on the basis of the direction of minus h gain, I again reach at one loop, okay, a closed path. Now with this green color, maximum one loop is completed. Now I am talking about second loop, so I start from x1, on the basis of the direction of g2 gain, I reach at x3 directly, okay, but I cannot close it because the direction of 1 is opposite to my direction, so this is not a forward path, this is not a loop, okay. So there exists only one loop, there exists only one loop, number of loop is 1, only one loop exists there, okay. And now the next step is write down the loop gain. So loop gain is denoted by, because only one loop, so L1 is there, and what is the gain? G1H minus G1H, because G1 is with positive sign but H is with negative sign, so when we multiply these two gain, then G1H, so minus G1H is my loop gain, okay. Now what is the next step? Find out the value of del 1 and del 2. Find out the value of del 1 and del 2. Now what is the rule to find out the value of del 1 and del 2? Del 1 is which loop do not touch the first forward path. Here only one loop is there, so check whether this loop touch the forward path or first forward path or not touch the first forward path. First forward path is G1, the purple color in the diagram, 1 into G1 into 1 into V3. So this loop is over there, so it touch the forward path, so the value is 1. Okay, similarly, as I have already been discussed, del 2 is check whether this loop touch the second forward path or not touch the second forward path. So see, this only one loop is there, minus G1H, minus G1H. The second forward path also include the x1 node. See the blue, light blue color line, the forward path is there, line, the x1 node is there, so it also touch, so x2 is also 1, so del 2 is also 1, okay. Not x2, del 2, so del 2 is also. Okay, I encircle this one also with a black color. Okay, so one more things I find out for the formula, the numerator term T1 I find out, T2 I find out, del 1 I find out, del 2 I find out. I only want to find now del. So as I have already been told, what is the formula for the del? So del is equal to, I just copy the formula from the previous question which I just taught you. So del is equal to 1 minus sum of all the individual loop gain plus sum of products of two non-touching loop minus sum of three non-touching loop and so on and so on. But for this question, now check, del is equal to so del is equal to 1 minus sum of all the individual loop gain, but here only one loop is there. So which one is individual loop gain? Minus G1H, because minus sign is already present, so it will be plus G1H, okay, 1 plus G1H, okay, plus sum of products of two non-touching loop, but here only one loop is there, so we cannot write down anything. Next, so now this del I also find out. Okay, so now I just write down the final answer by putting all these values in this formula. So CS upon RS is equal to T1. So what is T1? T1 is G1 del 1, but del 1 is 1, so there is no meaning to write down over there, because G1 multiplied by 1, that is equal to 1 also. G2, T2 is G2, and del 2 is 1 divided by, so I just write down divided by del, and del is what? 1 plus G1H, 1 plus G1H. Okay, so this is completed once again, and this numerical is ended. So this numerical is also ended. Okay, so with the help of signal flow graph, a very common strategy is follow the step-by-step procedure. First, once again I repeat and then end today class. So with the help of signal flow graph, we can also find out the transfer function of any system like the block diagram prediction technique, but here we use Mason's gain formula, and the Mason's gain formula is Tk del k upon del, where the value of k depends on the number of forward paths. T denoted for the forward path gain, del 1, del 2, del 3, it just to show you which particular forward path is not touched by which loop, and del means 1 minus sum of all the individual loop gain plus sum of the product of two non-touching loops minus sum of the product of three non-touching loop and so on. So we just follow the step-by-step procedure which I told you, which I discussed with you during the time of PPT presentation, and in this two numerical which we discussed today, we just follow the same things. I hope you understand very well. So now, okay, thank you.